Assalamualaikum and hi, my name is Shafiellya Hanim. We will present to you our group project that titled Round Robin alongside with my group members. Beforehand, I would like to introduce my fellow members that are Gabriel, Feng, Loke, and Muhammad Syabil. CPU scheduling is basically a process of determining the priority of the execution of the processes involved, where the remaining processes will be on hold while one of the processes is executing. The main task of CPU scheduling is basically to ensure that whenever the CPU remains inactive, the operating system will at least select one of the processes available in the ready queue for execution. CPU scheduler will be the one who carries out the selection process. The CPU scheduler will then select one of the processes in memory to be executed. There are several types of process scheduling algorithm. The first one is first come first serve, FCFS, shortest job first, SJF, shortest remaining type, priority scheduling, multi-level queue scheduling, and last but not least, round robin scheduling, which is our main discussion topic for this project. What is round robin? Round robin is a scheduling algorithm which can be said that it is the oldest and simplest among the existing scheduling algorithms. The name origin of this algorithm is from the round robin principle, where each person will get an equal share of something in turn. It is commonly used for scheduling algorithms that are multitasking. Besides, it can also be known as preemptive process scheduling algorithm. Being similar to the round-robin principle, each of these round-robin scheduling process is given a fixed time for execution, and this is called as a quantum. After a process completes its execution for a given time period, it will be preempted and the other processes will execute for the same period of time as the first process. Context switching, which means switching a task or process from the CPU to another, is used to save states of the preempted processes so that these processes can be reloaded when needed and the execution will continue from the previous saved state.
Okay, my name is Syabil. Hello. I will continue the slide about the round robin advantage and disadvantage. Okay, round robin advantage. Every process gets an equal share of period of time from the CPU, so the priority is given to all processes. Round robin is cyclic in nature, mean there is no starvation and no process left behind. It handles all process without regard to the priority. It performs the best term of the average response time. And lastly, for the advantage, if the total number of the process is known, then the worst case response for the same process are predictable. Okay, let's move on to the disadvantage. For disadvantage, for the round robin scheduling, the average waiting time under the round robin policy is often long, and if the time quantum is longer than needed, it tends to exhibit the same behavior as the first come first serve scheduling algorithm. If many tasks are given high priority, low priority tasks may have to wait longer. High priority tasks may not complete all instructions at the allotted time. Round robin scheduling spend more time on the context switching, and lastly, it reduces comprehension. Okay, that's all.
Hello, my name is Gabriel Feng and I am from Group DKMA, and I will be presenting the source code, discussion, and outputs of our round robin process scheduling. So this is our source code for the process scheduling a round robin. As you can see, it is like this. And this is the output and discussion for our round robin process scheduling. So here I will try to run the program following the examples. We'll use 4 number of processes. The first burst time is 21, the second one is 3, third one is 6, the fourth one is 2, with a time quantum of 5. And this is the example and the result of the round robin, with an average waiting time of 11 and average turnaround time of 19. So how does this round robin work? For round robin, there is an assigned fixed time slices called quantum to process as they are scheduled. Each process in the queue is allocated the CPU through the amount of quantum set by the designer. It is a starvation-free algorithm where each process is continuously processed until it finishes its available burst time. The execution begins with process P1, which has a burst time of 21, which is shown here. Here, every process executes for 5 seconds because of time quantum equals to 5. P2, P3, and P4 are still in the waiting queue, which is behind here. Since at time 5, P1 is added at time 5, P1 is added to the end of the queue and P2 starts executing, which is here. Since P2 has a burst time of 3, it completes execution at time 8, which is here. P3 starts executing at time 8 here. At time 13, P3 is preempted and added to the end of the queue. This P3 is added to here. P4 starts executing at time 15. P4 completes execution because of only burst time of 2. Yeah. At time 15, P1 starts executing again. At time 20, P3 starts executing. P3 has a burst time of 6. It has already executed for 5 intervals, which is here. At time 21, P3 completes execution. Then P1 starts execution till it is complete of its burst time. That is all for me. Thank you.
Selamat sejahtera kepada doktor. Nama saya Loke dan saya merupakan salah satu ahli kumpulan kepada Group 1 dan tema projek kami ialah Round Robin Principle. Saya akan menggunakan bahasa Inggeris untuk perbincangan seterusnya. So this is the conclusion for our project. CPU scheduling algorithms are crucial or important in achieving maximum CPU utilization, aiming to make the system efficient, fast, and fair. As one of the preemptive scheduling, where tasks are usually assigned with priorities, round-robin principle gives full play to its own characteristics by providing a specific time for processes that are being executed. This means that for each process that is involved in the execution, round-robin principle will ensure that the time given to each process is equally same, so that the processes can be executed fairly. Based on the researches and the output of the executed job program that we shown in this project, round robin's characteristics are obviously shown, such as its simplicity implementation and starvation-free capability, as all of the processes involved get fair share of the CPU. This is also why round robin is one of the oldest, fairest, the most commonly used technique in CPU scheduling as a core nowadays. However, this do not lead to a conclusion where round-robin scheduling is the only one that is useful in CPU scheduling processes. Every CPU scheduling algorithm that exists nowadays, such as first in, first out, FIFO, and also the others that can be found, has their very own capability and functionality. Thus, we should make researches about the functionality or the characteristics of the CPU scheduling algorithms before we make or execute one CPU scheduling process so that we can achieve the maximum CPU utilization. Thank you.